Welcome to our solutions and notes for day 13 of our GCSE 5 a day. And we start question 1 with a rounding question. And we're rounding to the nearest 100. So let's have a look at that on a number line. We are counting in hundreds, 500, 600, 700. Let's have a think about where our number 548 is. Well, halfway between 500 and 600 is 550. Halfway between 600 700 is 650. So our number 548 is just this side of 550. So we can see that it's actually physically nearest 500. And as the numbers pass 550, they would become nearest 600. Let's have a think about how we might do that without using the number line. So there's our hundreds, tens and ones column. And where we're being asked to round at this point here after the hundreds column. So what we're going to do is we're going to look at the next column along where we've got a 4, and we're going to say, is this greater than or equal to 5? No. This hundreds digit stays that it is, and everything beyond it becomes 0. So our answer is 500. And if you want a century nugget to look further at that topic and do some extra questions, then go to 2.13. Okay, question 2 is where we have to do a substitution of values into this algebraic expression. Now, there are a couple of issues going on here which might make things complicated. The first is that we have a negative number, and the second is that we may not be sure what this algebraic expression means. Now, when we have algebraic expressions like this without any operators in, then the invisible operator is always a multiplication sign. So what we're being asked to do here is to have 5 multiplied by what's our value of x? Well, that's also 5. And then we're going to multiply by -7. Okay, well, 5 times 5 is 25. And we're going to be multiplying a positive number by a negative number. So my answer is negative. Let me quickly go away here and do this multiplication. 7 times 5 is 35. So we'll carry the 3. 2 sevens are 14. 14 and 3, 7. So negative 175. Okay, so if you want to go and practice some more substitution questions, then go to Nugget 17.14. If we were a little bit unsure about some of our algebra basics, then go back and check there. If we had an issue with our negative sign, then go away and practice that at 3.04. And don't be embarrassed to go back and practice stuff with negative numbers. Negative numbers are a problem for so many students, and questions that you can do perfectly easily with positive numbers, if they start going wrong with negatives, don't think that you can't do the exercise. Just go back and improve your fluency with negative numbers. Okay, questions 3 and 4. We've got 2 currency conversions here, and I'm going to solve them as I have done in the past using a ratio table. And the information that we're given is that £1 represents $1.5. Okay, now the nature of the ratio table is that these numbers are in proportion. So if we had £2, we would have $3. If we had £10, we would have $15. So question 3 is relatively straightforward in this instance. We have 20 and we're asked how many dollars is that? Well, that is 20 times 1.5, which is 30. Now you've been doing these 5-a-days for a while, so you should remember now that we need to include our units. Now, I will include at this stage a couple of century nuggets to go and look at. First is 16.01, which is how the ratio table works, and for some further currency conversion questions, go to 37.10. Okay, now let's look at question 4, and we've got the same exchange rate. But in this instance, what we're given is we're given the dollar amount and we're asked what is the value in pounds. Now, there are 2 ways to do this exercise, and I'm going to take you through both. The first of all is to use an inverse operation approach, which is to say that if in this expression here we know that we are multiplying by 1.5, then to go the other way, we are dividing by 1.5. So we can go away and do our division. Now, I'm not going to labour how to do this division here. Do it on a calculator, or we can talk another time about how to do it manually, but that comes out as 300. Let's remember our pound sign. The other way to do that is to actually use our normal ratio table approach, which is to say that we know that $1.5 is £1. So in order to find $1, we would divide by 1.5. Then if I wanted to find 400, I would take this value here and multiply by 400. Now, our BIDMAS rules tell us that we can do division and multiplication together, and that means it doesn't matter which order we do it in. So in this instance, we are dividing by 1.5 first and then multiplying by 450. In this approach, our first approach using inverse operations, we did those operations the other way around. But if we go away, and as I say, just check this on your calculator and you will find that sure enough, that also equals 300. And for this question 4, you have the same century nuggets as we did for question 3. Okay, question 5. Well, this is a very wordy question, so we've got to try and pull the meaning of these words, and the way we're going to do that is by using our usual representation of a ratio. So let's do this first sentence here. The ratio of red to green is 2:5. Now, our representations of ratios end up looking very similar to our representations of fractions, and one of our key concepts is that we always have equal parts. So each one of those red and green parts that I've drawn here are all equal. So 2 red parts and 5 green parts. And we are then told that in this second sentence here, that the ratio of green to blue is 1:3. So each one of these green parts represents 3 blue parts. So we've got 3 blue parts for every green part. And we can see what our answer is going to be here, which is that we have now got 15 blue parts, 5 green parts, and 2 red parts. So if we're asked to work out the ratio of red to blue, that is 2 to 15. Okay, and if you want to go and do a century nugget on that, have a look at 15.05. Now I'm just going to do that now as well without the diagram. So we've got red, green, and blue here, and we have a ratio of 2 to 5, and we have a ratio of 1 to 3. Now, we can't say anything about red and blue until these 2 overlapping numbers are the same. And so we need to think of what equivalent ratio can we use to turn my 1 to 3 into a 5 to something ratio. Well, what we can see here is that we've multiplied by 5, so I'm going to need to multiply this by 5 as well. So we now have 5 to 15, so that I can see that the ratio between the 3 parts is 2 to 5 to 15. And that's done without using a picture to help us. And if you want to think even more mathematically about that, the principle here is to find a number which is the lowest common multiple of 1 and 5. So that's the end of question 5, and that's the end of our notes and solutions for day 13 of our GCSE 5 a day. I hope you found those useful, and please have a look at today's 5 a day questions